Good evening, students. So last class we were discussing about the MCQs on D and F block elements. So we will continue with the same. So last class we have completed MCQs on electronic configuration of D block elements. Then we have seen general properties. Okay, so on that topic also we have solved some MCQs. Then we had discussed upon some important compounds of transition elements. Did we start with that? Yes, we have started that. Okay, so we'll continue with the same. So we'll see some questions. Okay, so we have discussed this. Which one of the following ions exhibit DD transition and paramagnetism as well? 39 question. Chromate ion, dichromate, MnO4 minus, MnO4 2 minus. So this was a question asked in NEET 2018. So which one of the following ions will show exhibit DD transition and paramagnetism as well? Yes. We have discussed this, I think, this question. Okay, before going to this, how was your exam, NEET exam? Sunday you have answered, no? NEET exam, how was it? So your results are out. Okay. So Priyanka has scored 66 out of 100. Komal has scored 78 out of 100. Then Jyoti 36 out of 100. Then again, who is there? Anvita. Anvita has not appeared. Okay. Then Komal M. Harshita has not appeared. Nagini has scored 42 out of 100. Netravati 54 out of 100. Okay, so these are our scores. So whoever has not answered yet, okay, they can answer till Wednesday. So till Wednesday, still you have, okay, still you have the chance to answer the test. You can go through the link and you can just answer the test. Okay, and okay, so who is highest? Ulhas. Ulhas has scored 84 out of 100, and Komal. Okay, Komal has scored 78 out of 100, and one more, Meghna K. Okay, she has scored 76 out of 100. So congratulations, good. Okay, so you have to answer the test regularly, so it will boost your this. Okay, so it will encourage yourself only. So next time do again well. Okay, so everyone should answer the test. Fine. Now coming for this question, nobody has answered it still. which one of the following ions will exhibit DD transition and paramagnetism as well? Okay, so when you see the electronic configuration, okay, in CrO4 minus, in CrO4 2 minus, chromium is +6. Okay, so that time number of electrons will be 0. So the number of electrons when it will be 0, so means what? There are no electrons for paramagnetism will occur when you have unpaired electron. So this will be diamagnetic in nature. Okay, so this will be diamagnetic in nature. Then in dichromate, okay, in dichromate, that is Cr2O7 2 minus, what is chromium? So chromium will be +6. Again, N will be equals to 0. So again, this will show what? This will be diamagnetic in nature. Okay, so diamagnetic means what? When the electrons are paired. Okay, then in MnO4 minus. Okay, in MnO4 minus, Mn will be in +7 state. So N will be 0. Okay, when N will be 0, it will be again diamagnetic in nature. Then in MnO4 2 minus, what will be Mn? So Mn will be +6. Okay, so N will be equals to 1. So there will be one unpaired electron, so which is responsible for paramagnetic behavior. Okay, so which is our answer? So for DD transition, so the ions which show DD transition and paramagnetism as well is Mn. Okay, MnO4 2 minus. Fine. So we'll go for the next question. Name the gas. Okay, name the gas that can readily decolorize acidified KMnO4 solution. A. SO2, B. NO2, C. P2O5, and D. CO2, that is carbon dioxide. Yes. So you have to name the gas that readily decolorizes acidified KMnO4 solution. So the gas which is responsible for acidifying. So you know that pink color. Okay. So KMnO4, when you react KMnO4, okay, KMnO4 with SO2 gas, that is sulfur dioxide gas and water. Okay, so it will give you K2SO4 plus 2 MnSO4 plus 2 H2SO4. Fine, so this will turn the pink color of KMnO4, okay, to colorless. Which is the gas? It is SO2. So SO2 gas, it decolorizes the pink color, okay, to what? To colorless. Okay, so this is a reaction. So we'll go for the next question. I think I have solved these questions in the previous class. Okay, so we'll go for the next question. So which one of the following statement is correct? When SO2 gas is passed through acidified K2Cr2O7 solution, A. SO2 is reduced. B. Green Cr2SO4 thrice is formed. C. The solution turns blue. And D. The solution is decolorized. Okay, Priyanka has answered. So this is B. Okay, last class we have solved this. I know, remember. So 41. So I'll write the reactions again. K2 Cr2O7. When you have acidified means what? You have to treat it with concentrated H2SO4. Then SO2, it gives you what? K2SO4 plus Cr2SO4 thrice plus H2O. Okay, this is green in color. K2Cr2O7, it will be orange in color. So it turns it into green color. Okay. So SO2 gas, when it is passed to a acidified K2Cr2O7 solution, it turns it into green. So B is the answer. So we'll go for the next one. Assuming the complete ionization, same moles of which of the following compounds will require the least amount of acidified KMnO4 for complete oxidation? A. FeSO3, B. FeC2O4, C. FeNO2 twice, or D. FeSO4. Okay, so assuming the complete ionization. So when you assume the complete ionization, same moles of which of the following compounds will be required for least amount of acidified KMnO4 for complete oxidation? Yes. So KMnO4, okay, when you treat KMnO4, so you know that KMnO4, what is the oxidation state of Mn? It is +7. Okay, Mn is +7. So it changes KMnO4. Okay, what happens? KMnO4, it changes from +7 to Mn +2. Okay, when you are acidifying it, it changes from Mn +7 to +2. Okay, that is number of electrons involved per mole will be how much? It will be +7 minus +2. How much it will be? 5. Okay, it will be 5. So 5 electrons are involved. So you can see. So for 5 moles of this will be involved. So after that, for FeSO3, okay, for FeSO3, if you calculate what will happen to Fe, so Fe will be from oxidation state Fe+2, it changes from Fe+3. Okay, then so here from when it changes from Fe+2 to Fe+3, number of electrons involved will be 1. And for SO3, SO3 minus 2 to SO4 minus 2. Number of electrons involved is how many? 3, and this is 1. So it will be 2. Okay. Now total number of electrons involved in this reaction is what? 1 plus 2 equals to 3. So this is not. This is wrong. Okay. We'll check for the next one. Next is what? FeC2O4. That is ferric oxalate. Okay. C2O4 is oxalate. So what will happen here? Here again, Fe will change from +2 to +3. So number of electrons involved will be 1. Then oxalate is C2O4, 2 minus, giving you carbon dioxide. Okay. So the number of electrons involved is 2. So 1 plus 2 will be again 3. So this is also wrong. Then FeNO2 twice. Then Fe will change from Fe+2 to Fe+3. Okay. Then NO2 is what? 2 NO2 minus, giving you 2 NO3 minus. So the number of electrons involved is here 1. Here the number of electrons is 2 and this is 1. Okay, plus 1. So this will be how much? Number of electrons will be 4 here. So it will be 1 plus 4 equals to 5. This will be 1 plus 5 is equals to 5. So number of here, how much it will be? 5 only. So this will be the answer. Then when we are checking, again we'll check for FeSO4 also. From Fe+2, it will go for Fe+3 oxidation. SO4 minus, here SO4 is already in this. Okay, SO4, FeSO4 requires, so for SO4 minus, it is SO4 minus 2 only. It will not undergo any change. Okay. So only the number of electrons required is what? 1. So the number of electrons, this is only 1. So for FeSO4, what happens? For FeSO4, least number of this. So the compound which requires least number of the compound which requires least amount of what they have asked, requires the least amount of acidified KMnO4. So here it requires 3, here 5. So here only 1 electron, right? So as FeSO4, it requires least number of electron, thus it will require least amount of KMnO4 solution. So answer will be FeSO4. So like this. So you have to just calculate the number of electrons which are involved. So after seeing the number of electrons involved, then you have to calculate if the least number of electrons are involved. That means least amount of acidified KMnO4 is used. Okay. So we'll go for the next one. So now we'll see some questions based on lanthanides. We'll see some questions based on lanthanides. Okay, so this is a question. Which one of the following statements related to lanthanones is incorrect? A. Europium shows +2 oxidation state. B. The basicity decreases as the ionic radii decreases from Pr to Lu, that is lutetium. Then C. All the lanthanones are much more reactive than aluminium. D. Cerium +4 solutions are widely used as oxidizing agent in volumetric analysis. So this was a question asked in NEET 2016. Yes. So you know that after calcium, the first few elements, okay, that is the first few members of the lanthanides are quite very reactive, right? Almost like the calcium. However, with increase in the atomic number. So as the atomic number increases, what will happen? Their behavior becomes similar to that of aluminum. So all the lanthans lanthanums are much more reactive than aluminum. So C is the answer. Okay. So as you go down the group, what will happen? The atomic number goes on increases. As the atomic number increases, the behavior, it will resemble to same that of the aluminum. So option C will be the answer. So these are all theoretical questions. Okay. Then next question, the electronic configuration of europium, atomic number is 36, then GD atomic number 64, and TB atomic number 65R. So this is electronic configuration. Okay. So when you write the electronic configuration, answer will be B. Okay. B is the answer. So when you write the electronic configuration, so this will be the answer. So 4F, xenon 4F7 6S2 is for europium. Then xenon 4F7 5D1 6S2 is for GD, and xenon 4F 4F9 6S2 is for TB. Okay, so these are the electronic configuration of lanthanides. Next question. Gadolinium belongs to 4F series. Its atomic number is 64. Which of the following is incorrect? Which of the following is correct electronic configuration of gadolinium? Okay, A xenon 4F9 5S1, B xenon 4F7 5D1 6S2, then C xenon 4F6 5D2 6S2, and D xenon 4F8 6D2. So these are all okay. You need to write the electronic configuration and then you can get the answer. Okay, so gadolinium. So when you write the electronic configuration, it will be this. Okay, xenon 4F7 5D1 6S2. So this is the electronic configuration. So you have to write the electronic configuration, go filling of the electrons, and you will get the answer. Because of lanthanide contraction, which of the following pairs of elements have nearly same atomic radii? Numbers in the parentheses are atomic numbers. Okay, so the bracket whatever the numbers they have written, that is their atomic number. So which is a pair which is having similar atomic radii? Okay, Nagini, Nagalambika has replied. What about others? Okay, good. So everybody all have answered it as A, that is zirconium and hafnium. Okay, zirconium and hafnium with their with their atomic numbers 40 and 72. Okay, so they both have nearly same atomic number because of the lanthanide contraction. Okay, so they have same atomic radii and it is due to lanthanide contraction. So option A is the right answer. So we'll go for the next question. Reason of lanthanide contraction: A, negligible screening effect of f orbitals; B, increasing nuclear charge; C, decreasing nuclear charge; D, decreasing screening effect. Yes, what is the reason for lanthanide contraction? A, okay, Komal has answered it as A, Nagini answered it as C, Jyoti has answered it as A, Naglambika D. Okay, so I'll tell the answer. So it is due to poor shielding of 4f orbitals. Okay, so it is answer A, negligible screening effect of f orbitals. So it is due to poor shielding effect of 4f orbitals. So what it will do, nucleus will exert a strong attraction. Okay, because of poor shielding, the nucleus will tend to attract the electrons, outermost electron more strongly. As a result, the size will go on decreasing as you go across as there will be increase in atomic number. What will happen? The outermost electrons will be held strongly by the nucleus. So it is due to what? It is due to poor shielding of 4f orbital. So A is the answer. Okay. So these are all theory based questions. So in this chapter, it is all theory based question. So so this was a question asked in NEET 2013. Which of the following lanthanide ion is diamagnetic? Atomic numbers are given: cerium 58, SM 62, europium 63, and YB ytterbium 70. So which one of the following will show diamagnetic? You know what do you mean by diamagnetic? When you write the electronic configuration, okay, in d orbit there should be no unpaired electrons. Okay, in d orbitals there should be no unpaired electrons, means there should be all paired. So if diamagnetic means what? All will be paired. So I'll write first for SM. Okay, I've got the answers also. SM plus 2. Okay, so the electronic configuration is what? 62. So it will be what? Xenon 4f6. Okay, then Zn 63, that is europium plus 2. Here it will be xenon 4f 4f7. Okay, then next is YB plus 2. What it is? Atomic number is 70. So this will be xenon 4f14. Okay, so when you write the electronic configuration, there should be no unpaired electron. All should be paired in the f orbitals. So cerium plus 2, electronic configuration is 58, and xenon 4f2. Okay, so what is the answer? Okay, Netravati and Komal has answered it as B. Okay, and B is the correct answer. So it is YB. So YB is the correct answer. Only YB is diamagnetic. Okay, so the YB is only diamagnetic. Others are paramagnetic in nature. So when you write the electronic configuration, only YB is. Which of the following oxidation state is most common among the lanthanides? A4, B2, C, D5, D3. So the common oxidation state, yes, it is D. Okay, it is D. So the common oxidation state of all the lanthanides is +3. The oxidation state +2 and +4 are also exhibited. Okay, so they are also exhibited by some of the elements. But these oxidation states are only stable in the cases where it is 4F0, 4F 7 or 4F 14 configurations are achieved. Okay, so +3 is the most common oxidation state among the lanthanides. +2 and +4 are also there, but +3 is the most common. Okay, lanthanides are, what are lanthanides? A, 14 elements in the sixth period, atomic number 90 to 103 that are filling 4F subshell. B, 14 elements in the seventh period, atomic number 90 to 103 that are filling 5F subshell. C, 14 elements in the sixth period, atomic number 58 to 71 that are filling the 4F subshell. D, 14 elements in the seventh period, atomic number 58 to 71 that are filling the 4F subshell. Yes. What are lanthanides? What are lanthanides? Okay, I've got the answer. Komal has answered it as A. Naglambika has answered it as B. What about others? And the answer is what? Okay, Nagini has answered it as C. Harshita C. Naglambika A. Netravati D. Answer is what? Lanthanides are what? Lanthanides are 14 elements in the sixth period, which is having atomic number from 58 to 71. Okay, that are filling the 4F subshell. Okay, so they are separately accommodated in the horizontal loop below the periodic table. Okay, and these are called as what? Lanthanide, you know. So in between their numbers is written, but it is placed at the bottom, right? Lanthanides are there and then actinides. So these are the 14 elements which is having from 58 to 71. Okay, so option C is the answer. What is the general electronic configuration of lanthanides? What is the general electronic configuration of lanthanides? What is the general electronic configuration of lanthanides? Okay, Priyanka has answered it as A. What about others? What is the general electronic configuration? Okay, Komal has answered it as A. Naglambika C. Jyoti A. Nagini has answered it as A. Okay, so the correct answer is, what is the correct answer? So the correct answer is A. Okay, A is the correct answer. So the general electronic configuration of lanthanides is N-2, F1 to 14, N-1, S2, P6, D0 to 1, NS2. Okay, so this is the general electronic configuration of lanthanides. Okay, so next we'll see some questions based on actinides. So the incorrect statement among the following is A, actinoids are highly reactive metals, especially when finely divided. B, actinide contraction is greater for elements to element than lanthanide contraction. C, most of the trivalent lanthanide ions are colorless in solid state. D, lanthanides are good conductors of heat and electricity. So this was a question asked in NEET 2021. Okay, so what is the incorrect statement among the following? Okay, Nagini has answered B. Nagini has answered it as B. What about others? Harshita D. Harshita D. Jyoti has answered it as C. Nagini has answered it as A. Then Nagini has answered again D. Yes. What is the correct answer? Incorrect statement. Which is the incorrect statement? Actinoids are highly reactive metals, especially when finely divided. Correct. It is a correct statement. Actinoid contraction is greater for element to element than antinoid. Yes, it is also correct statement. Lanthanides are good conductors of heat and electricity. Yes, it is also correct statement. The wrong statement is C. Okay. So most of the trivalent lanthanide ions are colorless in solid states. No. So most of the trivalent lanthanide ions are what? They are colored. Okay, they are not colorless in solid state. So option C is the right answer. The reason for greater range for oxidation state in actinides is attributed to what? A. Actinide contraction. B. 5F, 60 and 7S level have comparable energies. C. 4F and 5D levels being chosen in energies. D. The radioactive nature of actinides. So what is the reason for the why they show great number of oxidation state in the actinides? Why there is a range of oxidation state? Okay, Nagini has answered it as B. Naglambika has answered it as B. Okay, this was a question asked in NEET 2017. What about others? Yes, what is the answer? What is the reason for great range of oxidation state in actinoids? Priyanka has answered it as D. Okay, so the answer is B. Okay, so actinoids, they have a greater range of oxidation state due to comparable energies of 5f, 6d and 7s orbitals. So all their electrons can participate in bond formation. Okay, so this is the reason. So this is the answer. Which of the following exhibit only +3 oxidation state? So this is a question asked in mains 2012. Which of the following oxidation state exhibits only +3 oxidation state? A. Uranium, B. Thorium, C. Actinium, D. Barium. Yes, which will show +3 oxidation state? Okay, uranium will exhibit +3, +4, +5, and +6. Okay, then thorium exhibits +3, +4. Then actinium, it shows only +3. Then PA, it shows +3, +4, and +5. So which is the answer? It is C. Okay, C is the correct answer. So actinium only shows +3 oxidation state, while the others, they will show variable oxidation state. More number of oxidation states are exhibited by actinoids than by the lanthanoids. The main reason for this, why actinoid shows more number of oxidation states than the lanthanoid. What is the reason? A, more active nature of the actinoids. B, more energy difference between 5f and 6d orbitals than that of 4f and 5d. Lesser energy difference between 5f and 6d orbitals than between then that between 4f and 5d orbitals. D, greater metallic character of the lanthanides than that of the corresponding actinoids. Yes. Okay, Nagini has answered it as D. Why more number of oxidation states are exhibited by actinides and not by lanthanoids? What is the main reason? Okay, Nagalambika has answered it as C. Jyoti has answered it as C. Correct answer is what? Correct answer is C. The 5f orbitals, they extend into space, okay, beyond 6s and 6p orbitals, and they participate in the bonding. This is direct contrast to the lanthanides where 4f orbitals, okay, they are buried deep inside the atom, and these are totally shielded by the outer orbitals, and because of this they are unable to participate in the bonding. So C is the answer. So lesser energy difference between 5f and 6d orbitals than that of between 4f and 5d orbitals, because these 4f will be inside buried, okay, buried inside the atom, okay, and they will not be participated in the bonding formation. Which one of the following elements shows maximum number of different oxidation state in its compound? Which one of the following elements shows maximum number of different oxidation state in its compound? A, GD, B, lanthanum, C, europium, and D, AM. Okay, so maximum number of different oxidation states in its compound is shown by AM. Okay, it shows +3, +4, +5, and +6 oxidation state. It is due to large size and low ionization energy. AM shows. Okay, GD, europium, and GD, it shows only +2 oxidation state and +3 oxidation state. While lanthanum, okay, it shows only +3 oxidation state. So more number of oxidation state is shown by AM. Okay. So we'll see some applications. So match the catalyst with the processes. Catalyst V2O5. Okay. Then titanium tetrachloride plus aluminium trimethyl aluminium. Then palladium trichloride and nickel complexes. So you have to which catalyst is used for which process. Okay, you just match it and you have to tell which is the correct option. Yes. Where V2O5 is used? V2O5, it is used where? It is used in oxidation of SO2 gas, okay, in the manufacture of H2SO4. So 1 with R. Then titanium, this is used in polymerization. Okay, it is used in polymerization of ethylene. Then PDCl2, it is used where? It is used in the oxidation of ethine to ethanol. Ethanol, okay, ethanol. Then nickel complexes, it is used where? Nickel complexes, polymerization of alkynes. Okay, so it is what answer? It is A. So the correct option will be A. Okay, you can see. So after matching, so this was a question asked in NEET 2019 and Odisha paper. Okay, so these are some of the questions you have to just go through. Mercurous chloride and iodine, both when dissolved in water containing iodide ions. Okay, the pair of species formed is. So what is a pair of species which is formed? So Hg, so this was a question asked in NEET 2017. So HgCl2, okay, which will be aqueous when it reacts with iodide ions, okay, which is aqueous. What it forms? It forms Hg I4 2 minus I4 2 minus 2 plus 2 Cl aqueous, okay. So and iodine plus iodide. So when iodine reacts with iodide, it gives you what? I3 minus. It gives you iodate. Okay. So what is the answer? It is HgI4 2 minus and iodide ion. So it will be B. So when HgCl2, that is mercurous chloride, and I2, when both reacts with iodide ions, okay, it forms HgI4 2 minus and iodate ions, that is I3 minus. Okay, so this is the answer. Which of the following elements is responsible for oxidation of water to O2 in biological process? A, copper, B, molybdenum, C, Fe, D, Mn, that is manganese. Which is responsible for oxidation of water to oxidation of water to oxygen in biological process? It is Fe. Okay, it is Fe. Okay, Fe is responsible. When calomel, okay, when calomel calomel reacts with NH4OH, we get. What is calomel? When calomel reacts with NH4OH, calomel is what? So calomel is what? Hg. It is HgCl2. Okay, this is calomel. So when this reacts with NH4OH, what it forms? NH4Cl. So NH4Cl plus H2O plus Hg plus HgNH4 Cl. Okay. So if so what is the answer? HgNH2Cl. So it will be option number C. Okay, so these are all applications. So just remember it. So when calomel is what? HgCl2, mercurous chloride, when it reacts with ammonium hydroxide. Okay, what it gives you? It gives you HgNH2Cl. Okay, these are all objective questions. Okay, applicative. Photographic films and plates have an essential ingredient of. So what does photographic films and plates, which essential ingredient is present? Silver nitrate, silver bromide, sodium chloride, or oleic acid. It is silver bromide. Okay, it is silver bromide. So silver bromide, it is highly photosensitive and it is used in an ingredient for photographic films and plates. Okay, so it is silver bromide. Okay, so so these were some of the applicative questions. Okay, so these were the questions we had solved today. So this completes your D and F block elements. Okay, D and F block elements is theoretical. This is completely theoretical. Okay, you get objectives based on all theory based. Okay, so these are all theory based questions. So this completes our chapter. So next class onwards, we are going to start with electrochemistry. Okay, followed by after completing electrochemistry, we'll start with alcohol, phenols, and ether. Right. So next class we'll be starting with electrochemistry. Any doubts in this chapter about D and F block elements? It is all theory based. Okay. It is all theory based. So any doubts here? Any doubts in this chapter? Yes, others? Any doubts? Okay, fine. So, uh, so this completes D and F block elements. So if there is no doubts, okay. So next class we'll start with electrochemistry. So I shall end the session here. So we'll meet in the next class. And whoever has not answered the exam, please go through the link and you can answer it up till Wednesday. Okay. Up till Wednesday, you can answer the NEET paper. Fine. So thank you. We'll end the session.